Okay, we're going to start factoring trinomials and different groups and polynomials. If you don't understand greatest common factor, you're not going to be able to do this. So go back and make sure you understand greatest common factor, because that's what this lesson is going to be based on. Okay, I'm actually going to give you the steps first, and then I'm going to show you the steps as we go through this, okay? So this is steps to factoring. And like before, there's going to be actually two choices to this. And so I'm going to tell you both choices. I'm going to show you some examples, and then I want you to choose which one works for you and use it, okay? Always the first step is look for greatest common factor. If there is one, besides one, factor it out. This is often, people forget this step, and then they have a hard time because there's a greatest common factor that should have been factored out. Okay, and so every problem, I'm going to look for the GCF as my first step. Step 2, we did this before, identify A, B, and C. Step 3, we're going to use, I call it the magic X. That's not what it's really called. It's just a graphic organizer to split our center term. So we've been practicing the magic X. You're going to use the magic X here. Then step 4 is your choice. There's two choices. There's grouping or the box method. Now, let me put the steps under these. If you're doing A, so let me draw a little thing down the middle here. If you're doing grouping, the first thing under grouping is to write the first and last term. The second step is to split the middle term using the numbers from the magic X. Now, sometimes the middle term is already split, and that's what we're going to see today a lot. The middle term has already been taken care of, so we don't need to use the magic X. And you'll see where we do sometimes need it, and sometimes we don't. Sometimes part of the problem's been done for us. So we're going to make two groups of 2. You're going to use the GCF in each, greatest common factor of each group. And then the last step is hard to describe, so we're going to call it chunks and leftovers, and you'll see what I mean when I do this. Okay, so grouping does have a few more, feels like there's more steps to it, but some of you will find grouping makes more sense to you than the box method. The box method really is also grouping, it's just using a graphic organizer for the more visual learner. So the first thing in the box method is you're going to write the first term in upper left-hand box. I keep leaving off the last letter. I don't know why. The second thing is to write the last term in the lower right box. Then the next step is write the two numbers from your magic X with a variable in the leftover boxes. I'm going to say in the empty boxes. It doesn't matter which one goes where. You'll get the right answer no matter where you put them, okay? So then D is GCF of each row and each column. And then E is to write your factors. Now, this is not going to make any sense to you until you decide which one you want to use. Okay? So maybe you wait and write this all down after you decide. But what I'm going to do is I'm going to do a bunch of problems using both examples. Now today we're only going to deal with polynomials. So we're not going to use the magic x today, because if the middle term is already split up, then we don't have to use the magic x. It's like someone did the magic x for us, and so we don't have to do that. So that's where we're going to start. So there's less steps involved, okay? So let's start with example 1, and I'm going to do it both ways. So maybe you want to listen first and then go back and write the way you like. So let's start with grouping. Here's my problem. 49x to the third minus 35x squared plus 56x minus 40. As soon as I see it's not a trinomial, I don't need to worry about the magic x. If it's not a trinomial, we do not need to worry about the magic x. Somebody split the middle term for us. We already have a middle term. Here it is. So we can actually start. We don't have to. I do always want to check for GCF. So let's start there. So start at step 1, GCF. Is there anything that goes into 49, 35, 56, and 40? In this case, there isn't. So my GCF is 1. So I just write my 1 down. The second step is to identify A, B, and C. As soon as you see that you don't just have A, B, and C, you can skip down to your grouping or your box method. So I'm going to skip now down to grouping because I don't have 3 terms. So that means it's already been split for us. Okay, actually we can all the way get down to C because we've already have the first and last term written. So I'm just going to write it again because I'm going to need more room. And the middle term's already been split up for us. Okay? So then it says make 2 groups. So this is what I mean by make 2 groups. I'm going to look at this group and this group separately. In the first group, I'm going to take out my GCF. Well, what goes into 49 and 35? 7 does. And then how many x's can we remove from this? Remember, this is just like GCF from the last section. I have an x squared and x to the third, so I can take 2 x's out without creating a negative exponent. So what do I have left? 7x minus 5. Remember, I divided both of them, 49 and 35 by 5. Sorry, 49 and 35 by 7. And then I took off x squared, leaving 1x and no x's on that. Next group. So let's do our next group. I look at that one and I have 56x minus 40. So what comes out of that, this is a tough one, is 8. 8 goes into 56 and into 40. But I can't take off an x because there is no x on 40. Now here's why I like grouping. It has an internal check. The internal check is if your 2 chunks are exactly the same, you probably did it correctly. Okay, you could make a mistake and cause 2 mistakes and cause it right. But if your 2 chunks match, 99% of the time you've done this correctly. So what you do is you take the chunks and you write them down once, because that's your greatest common factor. So you write down your chunks in the first group, and then you write down your leftovers. Well, what's left over when I take the chunks off? Well, a 7x squared plus an 8. That's what goes in the other factor, 7x squared plus 8. What we've done is we've now grouped this and undistributed it. So we could, if we distributed this or used FOIL or used box method, we would end up with this problem back again. Okay? So this is our final answer for what we're doing now. If I ask you to factor, these are the 2 factors that when FOILed would equal that polynomial. Okay, now let's do the same problem, but let's do it with the box method. Okay, so the box method again, 49x to the third, I'm using the same problem, so you can kind of compare exactly what's going on and decide which one makes the most sense for you, okay? Again, the box method starts with GCF, and the second thing is to identify A, B, and C. I don't have an A, B, and C. So I'm going to skip down to the box method, and I'm just going to fill in my boxes. The first term goes in the top left corner. And I made 4 boxes because there's 4 terms. So 49x to the third. That's my first term. My last term, negative 40, goes in the end box. And then whatever's in the middle, or if I had to use the magic X, that's what goes in my leftover boxes. And it doesn't matter which one goes where. Now this is where, again, if you don't know your GCFs, you're going to have a hard time with this. So we're going to do the GCF of all the columns and all the rows. For every first column and every first row, only ever pull a positive. Only ever take a positive if you're in the first row or first column. So I'm looking at 49x to the third minus 35x squared. I know 7 goes into both of those. And I also know x squared comes out. So if you are a box method person instead of a FOIL person, this should look familiar. We're doing it backwards. We're starting with what's inside, and we're pulling out what was multiplied together to get the inside numbers. Okay, so that's all we're doing. We're doing the backwards. Undistributing, factoring out a greatest common factor. In the bottom one, we're going to factor out an 8. In the first row, again, just like I said, make sure you only factor out a positive, so 7. And we can factor out one of the x's. Now here's where we got to be careful. There's a negative here and a negative here, and we haven't taken negatives out. So this has to be a negative 5. And sometimes I'm not sure, so I'll go back and test it to see. So 7x squared times 7x, well, that'll give me 49x to the third. 7x squared times negative 5, good, that gives me the negative 35x squared. 8 times 7x gives me 56x, and 8 times negative 5 gives me negative 40. And the last step is to write these as factored form. 7x squared plus 8 times 7x minus 5. And again, if you were to FOIL or box this, you would get back exactly what we did, because we just did the opposite operation. Factoring is the opposite of distributing. Factoring is the opposite of FOIL or the box when you have stuff on the outside. Let's do one more example, and I'll do it again both ways. Again, you might want to just listen first, or maybe you want to try the one you think is going to be your favorite method. Okay, so here's the original problem. 96x to the third minus 84x squared plus 112x minus 98. Now, most of the problems on the homework don't have numbers quite this large. All right, so let's start with grouping. The first thing we always do with grouping or with box is GCF. And I'm going to look to see if there's a GCF. Is there something that goes into 96, 84, 112, and 98? And there actually is. They're all even, so the GCF is 2. So the first thing we're going to do is divide everything by 2 and create a new polynomial. So this would be 48n to the third minus 42n squared plus 56n minus 49. So all I did was take the original equation and I divided everything by 2. And now to make our life easier, we're going to just work with this polynomial. So once you've GCF'd it, taken out the greatest common factor, then you stick with the new polynomial that you've just created by undistributing that 2, factoring out that 2, okay? So this is what we're going to work with in our grouping. All right, next step is to look for ABC. Well, we already have an ABCD, so we don't need to do that, which means I have 4, so I can skip right on down to grouping part C. So that's always nice. I get people that are like, oh man, I don't know what to do with this. These are the nice ones. Someone did part of the problem for you. You don't have to do the magic X. It's already been done for you. So I'm going to rewrite this so we can regroup it. 48n to the third minus 42n squared plus 56n minus 49. And so let's group them. I'm going to look at each group separately. In the first group, what goes into 48 and into 42? This is not an easy one. It's 6. 6 goes into both of them. And then I can take an n squared, because there's an n squared on the 42. There's an n to the third, so the biggest I can take is n squared. So 48 divided by 6 is going to be 8. And I took 2 n's off and put them out front, so I only have 1 left inside. And then negative 42 divided by 6 is 7, but I took both of those n squares and put them out front. Okay? Next one. I'm going to look to see what goes into 56 and 49. I already did this problem earlier. That's why I know these so quickly. I divide them by 7. There's no n that can come off because 49 does not have an n. And here's hoping the chunks match. And they actually do. And as long as your chunks match, you can continue your problem. If your chunks don't match, something went wrong somewhere and you need to go back and start again. If our chunks match, we write the matching chunk just once because we're actually taking that as the greatest common factor. And then we put our leftovers in the other group. And if we were to FOIL this or box this, we would get back our original equation. Now we'd get it back without the 2 on it. So to make it completely right, we need to put the 2 on there to remind ourselves at the very end we have to multiply by 2. All right, let's take this same problem now, and I'm going to do the box method. Okay, so here's the original problem was 96 n to the third minus 84n squared plus 112n. Oh, I switched it from x's to n, sorry. Minus 98, doesn't really matter. Start with the GCF. And we already figured this out before. The GCF here is 2. So we actually are going to deal with an easier polynomial. It's going to be 48n to the third minus 42n squared plus 56n minus 49. Again, we only want to deal with our new and improved polynomial. We factored out that 2 to make it simpler for us. Okay? Now, I'm going to look for an A, B, and C, but I automatically see I already have 4 terms, which means I can skip right down to the box method step 1. In the box method step 1, we create a 2 by 2 box. Don't worry about that 2. We can bring it at the very end. First term goes in top left corner. Last term goes in the bottom right corner. Make sure you take the signs with it. If it's negative, make sure you put a negative on there. And then the middle terms just go in the other 2 leftover boxes or empty boxes. Notice I'm writing the terms. Now again, we're going to take the GCF of the numerator, the columns, and the rows. So the first one, 48n to the third and negative 40n squared. I don't want to take a negative here because it's a first one. A first row and a first column don't take out a negative. So I know it's divisible by 6 because I did this problem earlier. And I also know there's an n squared in both of them. So I'm going to take out an n squared here. That's my greatest common factor. In the bottom one, I could take out a negative, but the 56 is not negative. So I'm not going to take a negative yet. So I'm just going to take out a positive 7 because 7 goes into 56 is the biggest number that goes into 56 and 49. First row, don't take out a negative, so I'm going to take out a positive. 8 actually goes into both of these. And there's one n in both of them. Okay? Now, in the last one, we have negatives in both. So we are going to take a negative here. Because they're both negative, we have to deal with that negative, okay? And that's just a 7. Because a negative 7, because there's no n's on the negative 49. Now, again, if you wanted to double check it, you could go back and multiply what's on the outside, and you should get what's on the inside. So then our final answer is 6n squared plus 7. Notice I put a plus on there. You might want to write that so you remember that. And 8n minus 7. I will tell you this, factoring takes a lot of work and a lot of practice. But if you can learn this now, your life is going to be much easier in geometry and algebra 2. I have students that just failed the last test because they can't factor. So it just keeps coming back to haunt them. In algebra 2, I mean, they failed the last test. So please learn this. Go back and work it a second time. Figure out which one works better, box or grouping for you, and then start practicing it as much as you possibly can.